Hey guys, welcome back to another Algebra 1 lesson. This is a good lesson. This one's on arithmetic sequences. You might be thinking, how is that a good lesson, Miss Blevins? But this is a good lesson because it teaches us a shortcut to make things easier. Have you ever been given a list of numbers and you're like, I need to know the 100th one. The problem will ask you to find the 100th number in the list of numbers. And you don't want to sit there and list them all out to 100. Well, I'm going to teach you how to do that today. So we're going to begin by looking at some patterns, and then we're going to determine if those patterns are arithmetic sequences or not. And you might be thinking, what is she talking about? But I'm going to explain the vocabulary as I go through explaining the sequences. So let me write down a sequence here. I'm trying to follow along with your book so that it's similar. So I'm going to write down the numbers here from your book. It's number 22. I'm on page 251 if you're following along. But the number's 22, then 17, and then 12, and then 7, and then 2, and then I show the dot, dot, dot to show that it keeps on going. This should be a comma, and this should be a comma. Okay, so looking at my list of numbers here, this is called a sequence. You know, I'm not talking about the little shiny, shimmery things on the dance uniforms. I'm talking about a sequence as a list of numbers that have some sort of pattern to get from one to the next. Each one of these numbers in the sequence is called a term of the sequence. So 22 is my first term. 17 is my second term. 12 is my third term. So if I ask you to find the 100th term, you would just have to keep on going, keep on going, keep on going till you found it. Well, to determine if our sequence here is arithmetic or not, we look to see what is the difference between each number. If there is a common difference, I'm adding or subtracting by the same number each time, then I know that it is arithmetic. So to get from 22 to 17, I know that I go down 2, then I go down 3 more, so I went down 5. So I subtracted 5 to get from 22 to 17. So what would I do to get from 17 to 12? Could I still subtract 5? Yes, I can. So this must be an arithmetic sequence. We'll keep on checking. Yep, subtract 5. Yep, subtract 5. Each time to get from one number to the next, I subtract 5. So if I want to determine if something is an arithmetic sequence, I look to see, am I adding or subtracting by the same number each time? Think about the word arithmetic. Arithmetic's adding and subtracting. So if I'm adding or subtracting to get to the next number. So if I look at the number 2 or the sequence, 2, 4, 8, 16, 32. Is this an arithmetic sequence? The answer is no. There is a pattern. I add 2, then I add 4, then I add 8. We can see that we're doubling the previous number, but I'm not adding by the same amount each time. Therefore, it is not arithmetic. Not an arithmetic sequence. This would be called a geometric sequence, and we will get into that later in this school year. Okay, so moving on to our next slide. How do I find the next term? Well, we just covered how to do this, so I want you to take a minute to pause the video and write this down and find the next term for me. Okay, so first I'm going to identify, this is my first term. This 11 is the first term of the sequence. I'm going to call it A sub 1. It's my first term. This would be A sub 2. It's my second term. A sub 3 is my third term. A sub 4. So I'm looking for, what is A sub 5? Well, it's pretty easy to figure out what the very next one is, because from here to here I can see I subtracted 4 again, subtract 4 again. So get to the next one, I'm going to subtract 4 from -1, and I know that I get -5. So the fifth term of my sequence is going to be -5. Because -1, take away 4 more, gives me -5. So how do I find the 100th term then? Why even try, right? Who wants to sit here and list out all of these numbers, possibly make a mathematical error in one little thing, and get the entire problem wrong? You're probably thinking, yeah, I don't care enough to do that. I don't want to sit here for an hour and list out the first 100 terms of this sequence. So I'm going to show you this little formula. This formula says to find the nth term, this is the 100th, we're just calling it the nth term. To find the nth term of a sequence, we use this formula where we take the first term, the a sub 1, we add, we have to have the previous term. So to get from here to the next one, what did we do? We looked at this negative 1. It was our previous term, so we do n minus 1, the previous term, times the difference, our common difference. We're going to say d for difference. It's the rate of change here. Okay, so this is my first term. So in this problem, our first term is 11. We're looking for the 100th term. So 100 minus 1 is 99. Times our common difference. Our common difference is negative 5. I put that in parentheses because I don't want it to look like any n. 99 minus 5, I want it to be 99 times a negative 5. And this is going to give us the 100th term of our sequence. So 11 plus 99 times negative 5 is negative 484. That would be the 100th term in our sequence. So negative 484 is the 100th term. So why even try? I'll tell you why to try, because it's easy. It's so easy a caveman could do it, right? We just list the first term, do the term that we're looking for, subtract 1 times the common difference. Now, it wasn't easy when I thought I had to list them all out by 100. I'm not going to sit there and do that. That's way too much work. But it's very easy if you know the formula that I just taught you. So now let's try another problem. Let's write an equation to find the nth term. You can do this. I know you can. Pause the video and give it a try. Identify what is my first term. My first term is negative 4. Okay. Started off with negative 4. I'm going to add n minus 1 times my common difference. What's the common difference here? Looks to me like from here to here they added 3. So I'm going to check to see, did that work? Plus 3, yep. Plus 3, yep. So each time we are adding a positive 3. So my difference is 3. Now, if you want, you could go ahead and simplify this and have negative 4 plus 3n take away 3. And then we just combine like terms. Negative 4 take away 3 is negative 7. So a sub n equals 3n minus 7. Now it looks linear, right? We can see that this is a linear equation. If I was to graph this, it starts down here at negative 7. My slope goes up 1, 2, 3 over 1, up 3 over 1. And we can see that it is a positive slope, so it should be going up as it moves left to right if we wanted to look at it graphically. But this is our equation to find the nth term of the sequence. So if I wanted to find the 100th, 300 take away 7 is 293. So the 100th term would be 293. We could find the 257th term by plugging in 257, timesing it by 3, subtracting 7. We would get our answer. Okay, so now let's look at a real world problem. That's what we care about, right? I'm going to pretend that I'm opening a savings account to save for a trip to Italy. I have always wanted to go to Italy. The problem in the book had somebody else's name that talked about I'm going to Spain, but I want to go to Italy, so I changed it to suit my fancy. So with the cost of a plane ticket, food, hotel, and other expenses, got to bring back gifts for the kids, right? I need $1,600. Probably going to need a whole lot more than that. I'm beginning my savings account with $525, and every month I'm adding the same amount of money to my savings account. So it's kind of tempting to sit here and think, okay, let's list out the pattern. I began with $525 and then I added some money and then I added this much money. How much money am I going to have? How many months is it going to take me to get to $1,600? Well, we could sit there and list it all out, but I want to point something out to you. This 525, while it is my starting balance, it's how much money I put in my account. This is like saying I started with this amount. So it's instead of my A sub 1, it's my A sub 0. I started with this, but after 1 month, this is how much money. So to determine how many months it's going to take me to get to my goal, I want to use this amount as my starting balance. So I began with 5. After the first month, after the first month of savings, the initial amount is $580. I am adding how much money each month? What is my common difference here? Oops. Well, to get from 580 to 635, looks like I put in $55. Actually, to get from 525 to 580, I put in $55. So I put in $55 to get this amount of money the first month. So my common difference here is $55. So after the first month, I have $580. So how many months is it going to take me to save to get my $1,600? Interesting. How could I solve this? Oh, I know. Do what we learned how to do in the first, actually the second module that we covered this school year. So let's distribute this, combine like terms, and solve. So I have 580 plus 55n minus 55 equals 1,600. Let's go ahead and combine like terms on the same side of the equal sign by using the commutative property. I changed the order. So 580 minus 55 gives me 525. That's that initial amount I started with. So $525 plus 5n equals 1,600. That makes sense because if I plug in a 0 for 0 months of savings, I had $525, right? That's how much I began with. After 1 month, plug in a 1, 5 times 1, that should that be 5? No, that should be 55. Sorry, guys. 55 times n is 55n. There we go. Plug in a 1 here. So 55 times 1 is 55. So 525 plus 55. I don't know why I'm typing in the calculator. I know it's 580, I guess just to check. So after 1 month, I have $580. After 2 months, I'm going to have how much? After 3 months, I could keep going, or I could just solve algebraically and say, okay, 1,600 minus $525 is $1,075. So we have 55n equals $1,075. All I did was subtract the 525 from both sides. Now I know to divide both sides by 55, and it looks like it's going to take me, it says 19.54545454, keeps on going, months. Well, I'm not going to save. I notice it says that every month she adds the same amount of money to her savings account. So I'm not going to add a little bit at a time. I'm putting it all in at once each month. So it's going to take me 20 months to have saved up enough money. If I only do 19 months, I'm not going to quite have my $1,600. If I save for 20 months, I'm going to have the 1,600 that I need and a little bit more. So that would be good. Let's plug it in and see. 525 plus 55 times 20 months of savings gives me $1,625. All right, so now let's just kind of look at a graph to look at how this comes out. So I've already put the graph on Desmos. We had $580 plus x minus 1 times 55. So we can see that our initial amount that she began her savings account with was $525. Okay, we want her to have at least $1,600. So I can see here, this is a little bit more than 16. Right in here somewhere. Somewhere between 19 and 20 months, right? She's going to have to save for 20 months in order to get the right amount of money to go on her trip in order to have $1,600. All right, so I hope that made sense. Kind of just comparing the problems that we looked at before with graphing. We knew that this simplified to, what was it, 525 plus 55x equals y, or 55n. Same line, the exact same equation. The 55 is our y-intercept. It's where the line crosses the y-axis. Our slope is 55. We go up 55 over 1, up 55 over 1 to get to the number of months. That happens 20 times in order for her to have at least $1,600. So that takes care of this lesson. I hope it made sense. I hope you guys like this as much as I do. I like anything that makes my life simpler. And this equation makes your life a whole lot simpler if you have to find numbers way far out there in a sequence.